Dear viewers, welcome to Future Knowledge Bank here. This time I am giving the mathematics 3 stages. In the first level, I am giving the chapters here for the SSC exam to target 10 by 10. The first chapter is the real numbers I am giving here. You can see that one. The first important formula for the real numbers is Euclid's division lemma. In this case, you can see here A is equals to BQ plus R. In this, A is called dividend, B is a divisor, and Q is a quotient, R is the remainder. And here, the remainder always equal to 0 or greater than 0. But it should not be greater than B. That means divisor. So, R is greater than 0 or equal to 0 but less than B. This is the Euclid division lemma. On this, so many formulae we having. And comes to the point, the product of any two numbers, that means it may be any two numbers, n or n2, is equals to the product of their LCM, the two numbers LCM. If you are taking the two numbers LCM and two numbers HCF, we having one common formula here. Number 1, n1 into n2 is equals to LCM into HCF. These are the two formulae. And next, logarithm formulae. We having here 7 logarithm formulae. Log xa plus log ya is equals to log xy. That means log 5 base 2 plus log 4 base 2 is equals to log 5 into 4. That means 20 base 2. Like that you are having. Now second formula, log x base a minus log y base a is equals to log x by y. And next, the log x to the power of m base a is equals to m log x base a. Here m is a character and log x by a. Now that means the power is becoming the character over here. Now next one, the fourth one, log x base to the power of m. Now we are having the power here for the base. So when we have the power is a base, the power will become inverse character, reciprocal character of the logarithm, 1 by m log x a. Next, the log 1 base 7 is equals to 0. That means the log 1 of base anything is equals to almost all 0. Thereafter, the log a base a is equals to 1. Here is the last formula. A log n base a is equals to n. That means character and base are similar. Whatever the log value is there, that is the final value n. That means, for example, one example I am giving here. The character is 2 here, log value is 5 here, base is 2. Now, character and base are same, then the log value is 5 here. So, that is the last formula. Next, determine the values. Here, some few sums are there, very important ones I am giving here. How to determine the log values here. Log under root x base x is equals to log x to the power of 1 by 2 base x. That means here root value is nothing but 1 by 2. So that means I am converting this root into 1 by 2 value here. So now log x power 1 by 2 base x. Here according to the formula 3, that means log x to the power of m base a is equals to m log x. In this way, the power will become character here. So now half will become character and log x base x. So log x and base x means that is a 1. So half into 1 is equals to half. This is one interesting sum. Here, then one important sum I am showing here. 2 to the power of 2 plus log 3 base 2. How to do this sum means here 2 is having one power 2 plus log 3 base 2 another power. That means this log 3 base 2 also is a power of the same base. That means we have to see here 2 square into 2 log 3 base 2. That whenever the bases are same, power should be added. That concept point of view, we are bringing the power back here. Then now here according to the seventh law, a log n base a is equals to n point of view. Here you can see 2 square means 4, 2 log 3 base 2. That means here when our character and base is same, the value 3 will be the final value. So now 4, 2 square means 4, here is a 3, 4 into 3 is equals to 12. This is the important sum. Here 3 important long sums are there. The first one is if x square plus y square is equals to 25xy, then prove that 2 log x plus y is equals to 3 log 3 plus log x plus log y. This is the most important sum. I think you already know it. Next, another sum. If 2.3 whole to the power of x is equals to 0.23 whole to the power of y is equals to 1000, then find the value of 1 by x minus 1 by y. This is one more important in the logarithms point of view. Now, the third sum is if 2 to the power of x plus 1 is equals to 3 to the power of 1 minus x, then find the value of x here. Now here I am showing the important sum solution here. If 2 to the power of 3 power of x is equals to 0.23 power of y is equals to 1000, then find the value of 1 by x minus 1 by y. This sum, how to do, I will show you now. First of all, I will take 2 to the power of 3 power x is equals to 1000. Then 2 to the power of 3 to the power of x is equals to 10 cube. I am converting 1000 into 10 cube. Next, 2 to the power of 3, I am sending the power to the other side, 10 to the power of 3 by x. This is going to be considered as equation 1, not the above one. This is equation 1. Then I am taking the next relation, 0.23 to the power of y is equals to 1000. Here 0.23 to the power of y is equals to 10 cube. I am converting 1000 into cube. Then 0.23, this power I am sending to the other side, it will become 10 to the power of 3 by y. This is the equation 2. Now, one combined format I am bringing for the equation 1. What is the equation 1 here? 2.3 equal to 10 to the power of 3 by x, equation 1. Here equation 2 here, 0.23 is equals to 10 to the power of 3 by y. And one common equation I am bringing to use these both the values. To use this both the equation values here. What is the common one? 0.23 is equals to 2.3 by 10. That means if you are dividing 2.3 by 10, you will get 0.23. So in this way also it will be perfect. Now here I am placing what is the value of 0.23. According to the equation, the 0.23 value is 10 to the power of 3 by y is equals to the 2.3 value in the equation 1 is 10 to the power of 3 by x, then 10 to the power of 1. Now since bases are same, power should be equated. 3 by y is equals to 3 by x. This power I am going to send up, minus 1. Now 3 by x, I am bringing the 3 by y this side, 3 by y is equals to 1. So now being this one, the 3 is a common here, 1 by x minus 1 by y is equals to 1. So now finally what is the value of 1 by x minus 1 by y means, because of multiplication it will become the reciprocal, that is 1 by 3. So therefore the value of 1 by x minus 1 by y is equals to 1 by 3. This is an important interesting sum. Here I am showing some important problems in the real numbers. 1.1 exercise, that is a use division algorithm to show that any positive odd integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5, where q is the sum of integer. The second sum, use division algorithm to show that the square of any positive integer is in the form of 3p or 3p plus 1. The next one, use division algorithm to show that the cube of any positive integer is in the form of 9m plus 1 or 9m plus 8. You can see here one interesting point. In the first sum, you can see odd integer. Here to concentrate, odd integer we have to find out. In the second sum, the square of the positive integer. The third sum, the cube of positive integer. So here is an odd one, here is a square, and here is a cube. And some more problems are there here. Prove that the following are irrational. These are the important ones. Root 3 plus root 5, first bit. Second one, 6 plus root 3. Third bit, 3 plus 2 root 5. And in the meantime, you are having determined the values and the following these sums. Now I want to show this very interesting sum in working nature. Use division algorithm to show the cube of any positive integer is in the form of 9m plus 1 or 9m plus 8. How to do this sum is very interesting one. See, the solution I am already doing here. Let a be the cube of any positive integer. Applying Euclid division lemma for a and b is equals to 9. Why? Because here 9m plus 1. Here 9 is the divisor, m is the quotient, and 1 is the remainder. So now a is equals to bm plus r, where m is the quotient and r is the remainder, where r is equal to or greater than 0 but less than 9. Now according to this, the possible remainders are 1, 2, 3, 4, 5, 6, 7, 8. Why? Because the remainder always greater than less than 9. So only the possible remainders will be up to 8. It should not exceed the 9. Next, after the possible remainders, the possible a values are 9m, 9m plus 1, 9m plus 2, 9m plus 3, 9m plus 4, 9m plus 5, 9m plus 6, 9m plus 7, 9m plus 8 are there. But all these values are cannot be a values. Why? Because the cube of the positive integer he said. That means 1 cube is 1, 0 cube is 0. So now 2 cube is 8. So the values can be applicable up to 9m plus 2. It cannot be exceed up to more than this one. So the what are the final values? A values means 9m, 9m plus 1, 9m plus 2. That means here 1 cube is 1 and 2 cube is 8. The final value is 8 here. So it will be the final solution. Now come to the point of the chapter number 2, sets. Example for the rooster form and set builder form. In a simple way I am giving here. Set A having the elements 3, 6, 9, 12 and 15. It is in the rooster form. That means rooster form means all the elements are placed separately with help of commas. And in the set builder form, that is short form will be there. You can see here the same set above set I am writing in the different channel in the set builder form. X such that x is a multiples of 3. That means 3, 6, 9, 12, 15 are the multiples of 3 less than 16. See, the last multiple is 15. That purpose we can write is less than 16. So it is in the form of set builder form. And comes to the point of the next one. If a set contains an infinite number of elements, it is called infinite set. If a set contains the finite number of elements, it is called finite set. So next one, if the set A contains the three elements 1 comma 3 comma 5, and another one is having the set B is having 5 elements 1 comma 2 comma 3 comma and 5, then we can say the set A is a subset of the set B symbolically. That means A is a subset of B. Now the next one, if two sets have no common elements, no elements in common, then the two sets are said to be disjoint sets. This is one interesting concept in the sets. That means in the set A, we are having 1 comma 3 comma 9. In the set B, we are having 2 comma 4 comma 8 are the disjoint set. No common elements here. 1, 3, 9 are different. Here 2, 4, 8 are different. So this is we can consider as A intersection B is equals to null. The number of elements in the finite set is called cardinal number. That means in one set 1 in the set 1 comma 2 comma 3 comma 4 comma 5, we are having the 5 elements here. The 5 elements is the cardinal number of the particular set. Cardinal number means the number of elements present in the particular set. Here some important set sums are there here. The first one is if A is equals to x such that of 2x plus 1, x belongs to natural numbers and x is less than or equal to 5. Now set B, x such that of x is a composite numbers, x less than or equal to 12. Then show that A intersection B minus A union B is equals to A minus B union B minus A. Now come to the point of the second sum. A equal to 1 comma 2 comma 3, B equal to 3 comma 4 comma 5. Then find that one A minus B and B minus A. Next the sum number 3. List all the subset of the set A x comma y comma z. Next the fourth sum is if n of A is equals to 26, n of B is equals to 5, then find n of A minus B and n of B minus A where B is the subset of A. There is an interesting sum. This one I am showing the solution for this. Now the solution for that above sum is n of B is equals to n of B minus A plus n of A intersection B. Here n of B is equals to 5, n of B minus A we have to find out, plus n of A intersection B is 5. So therefore n of A B minus A is equals to 5 minus 5, 0. Then comes the point of the another sum. If A comma B are non-empty sets where n of A minus B is equals to 25 and n of B minus A is equals to 15 and n of A union B is equals to 60. Now you have to find out n of A and n of B values. For this also I am showing the solution. N of A is equals to n of A minus B plus n of A intersection B. Now n of A is equals to n of A and B value 25 plus n of A intersection value is 45. And therefore n of A is equals to 25 plus 45, 70. And comes to the point of the second bit, n of B is equals to n of B minus A plus n of A intersection B. Now n of B is equals to 15 plus 45, n of B is equals to 60. In my coming videos, I will give very important problems for the solution point of view for your examination within a very short period. Work out and get the good result. And thank you for watching this video.